Okay, guys, so today we are going to do Chapter 7, Section 4, Solving Proportions. Unequal masses will not balance on a fulcrum if they are an unequal distance from it. One side will go up and the other will go down. Think of this as like if you're on a teeter-totter, right? For it to be equal and to be balanced, sometimes one of you has to scoot in or out to make it straight so that you're both across from each other. So unequal masses will balance when the following proportion is true. Remember, a proportion is two ratios that are equal, and a ratio is just a fraction. So the mass 1 and the length of 2 equals the mass of 2 and the length of 1. Okay, and there's an example with a picture right there. Mass 1 has a farther length, mass 2 has a shorter length, and then that makes them both equal. So one way to find whether ratios such as those are equal is to find a common denominator. The ratios are equal if their numerators are equal after the fractions have been rewritten with a common denominator. So a common denominator for 8 and 12 would be 24. Okay? So we make these both a denominator of 24. And remember, when we're dealing with fractions and common denominators, 8 times 3 is 24. Whatever you multiply the denominator by, you also have to do the numerator. So 6 times 3 is 18. 12 times 2 is 24. So again, 9 times 2 would be 18. Okay, so when we find common denominators, we get 18 over 24 and 18 over 24. So then, yes, those are proportional because with the same common denominator, they equal the same amount. All right, tell whether the ratios are proportional by using cross products. Okay, and we did this a little bit last week. All right, remember we could see if you multiplied across from each other, if the numbers were equal, then they were proportional. So 15 times 4 is 60, 6 times 10 is 60. If the cross products are the same number, they are also proportional. Okay, so you can have a common denominator, or you could have done 6/8 like we did last week, and you could have reduced these also. I'm going back up. 6 and 8 are both divisible by 3. 6 divided by 3 is 2. I lied. That's not going to work. Hold on. They're both divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. We get 3/4. 9 and 12 are both divisible by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So you can either find a common denominator or reduce up at the top, or you can use cross products. And that's all a review from last week. All right, so now for the new thing. A mixture of fuel for a certain small engine should be 4 parts of gas to 1 part oil. If you combine 5 quarts of oil with 15 quarts of gas, will the mixture be correct? So I'm going to write down the words that I'm comparing. So we have gasoline to oil. Okay, so the first one that they give us is 4 parts of gasoline to 1 part of oil. So I'm going to put 4 gas to 1 oil. If you combine 5 quarts of oil, so 5 needs to go across from the oil. See, everything with oil's in our denominator. Will 15 quarts of gasoline, will the mixture be correct? So I'm going to put 15 up here. Excuse me. So now I'm going to use cross products to see if that works. 1 times 15 is 15. 4 times 5 is 20. So that would be no. It is not correct because when we cross multiply, we do not get the same answer in the numerator or on both sides. All right, so here's the next one. Sorry about that. Okay, it says solve the proportion since one of the numbers in the proportion is missing. Okay, so we're going to still use the concept of cross products. But since they're equal, we're going to set them equal to each other. So 12 times 5 is equal to 6 times p, because just on the last slide, when you cross multiply, you should get the same answer if they are proportional. So now we do our multiplication. 12 times 5 is 60 equals 6p. Now it's just a basic one-step equation. We did these last chapter. You want to get p alone. So to undo multiplication, you're going to divide both sides by 6, and p equals 10. Now, if you don't want to do cross products, there's another way you could do this. So I'm going to erase this and go back. You can look at the problem and say 6 times 2 is 12. 5 times 2 is 10. And that works sometimes. That may not always work. Sometimes you may have to do the cross products, like I did over here on the right-hand side. But if it works to just multiply or divide, you can do that as well. So let's look at the next example. 2 times 7 is 14, 3 times 7, so G equals 21. Okay, you could have also done cross products, and you can pick whichever one works best for you. Like I said, cross products always works. The multiplying or dividing, sometimes it's not always a whole number. So 2 times G equals 14 times 3. Okay, so 14 times 3 is 42, so 2G equals 42. Undo your multiplication with division, and G equals 21. Okay, pretty easy stuff today. All right, last one. A shade of paint is made by mixing 5 parts of red, so we're going to have red over 7 parts of blue. Okay, so red over blue. So 5 parts of red with 7 parts of blue. That was just given in the first problem. 5 parts of red with 7 parts of blue. How many quarts of red paint, so that's what we don't know, are needed if you have 12 quarts of blue paint? So I just took those numbers right out of the problem. Okay, now here's like one I was talking about. 7 doesn't go evenly to 12, so cross products is going to be the better route to go this time. So 7 times x is 7x equals 5 times 12. 5 times 12 is 60. So we do 7x equals 60. Undo your multiplication with division. And 7/60th, how many quarts? So your answer is in quarts. 7/60th quarts, or if you want to make that a mixed number, your answer would be 7 goes into 60 8 times, which is 56, and 4/7 quarts. So you either have 67 quarts or 8 4/7 quarts, and I would accept either of those. Okay, so great job today. Have a good night, and we'll see you tomorrow.